Hi everyone, this is Sharan. Welcome to my channel. Today in this series of learning data science in 100 days, we are going to see about statistics. Statistics has huge number of use cases in data science project. To mention some of the few use cases, to start with, let's say we have millions or even thousands of customers' data. We want to run a survey to understand the customers' behavior or what the customers thinks about the product or whatever it may be. So in order to do that, we need to pick up and sample from the larger population. In statistics, there are various techniques that helps us in coming up with these random samples. Actually, today we are going to see in detail about the various sampling methods and how to implement them using Python. And the next one is, let's say we have the data. We want to better understand about the data. Statistics provides us with various descriptive statistics techniques that helps us to understand the data better. And when we have multiple variables in the data set, we want to understand the relationship between them. So again, there are various methods that are available in statistics that helps us to better understand the relationship between different variables, such as covariance and correlation. And there are various causal and effort analysis as well that helps us to understand if there is a causal effort pattern in the data. And there are a few other statistics tests such as z-test, f-test, triced-wire test that helps us in order to get the inference from the data, get some insights from the data to check if there is any patterns available in the data set as such. So we are going to see about all these use cases in detail over the next few days. So for today, what we are going to do is we are going to get into the details of various sampling techniques that are available, and we are going to go through some of them and see how to implement them using Python. To start with, there are non-probabilistic as well as probabilistic sampling methods. In case of non-probabilistic sampling methods, we randomly we identify data points, maybe based on expression of interest, or maybe based on something that is not actually probabilistic based. For example, let's say we want to do an analysis about the behavior of various shoppers. And if we go to a mall and then conduct this particular research, it is a non-probabilistic sampling because people who are coming to the mall have an intention of buying something, like most likely. And if we are going to pick up and sample from this particular subset of people, it's going to be non-probabilistic, which means that it is not going to reflect the actual real data out there. There are a lot of other people who are totally not interested in shopping at all. So that's called as non-probabilistic sampling. The second one is the probabilistic based sampling methods. So here there are quite a number of techniques available. We are going to see some of them, and then we are going to see how to implement them. So the first one is simple random sampling method. So here, right, every individual in the population has equal probability of being selected. So we come up with some totally random sample from the whole population with an assumption that it is going to reflect the actual population. And the second one is instead of going for a total random sample, we follow a systematic approach. Let's say we have a customer ID. We select every nth customer from the database based on the customer ID and use that for our sampling method. We assume that by this method we have the whole range of customers who joined like long back as well as customers who joined recently, and we assume that this might also reflect or might be close to the actual population. And the other one is cluster based sampling. Let's say we have a large number of customer base. What we do is we cluster them into different groups based on a specific behavior or based on the purchase behavior or based on whatever characteristics that is applicable for that use case. And what we do is from each of these clusters, we pick up some random sample and come up with this sampling, come up with the sample for our analysis. So this is called as cluster based sampling. So in cluster based sampling, it can be multi-stage cluster based. So where after selecting a particular cluster, we can go and select the nth element within those clusters, like nth customer within those cluster. So which would be like a multi-stage. We can also have we can also add on conditions as much as possible. Like within a particular cluster, we can try to come up with a subset and identify the customers within the particular subset. So, and this last one is the stratified sampling method, so which according to me would be very close to the actual population. So by stratified sampling, what we are trying to do is we try to retain the distribution that is present in the original data set. For example, let's say in our population, we have customers who are about 40% of them are male and 60% of them are female, and we know various details like which country they reside on, what's their salary bracket, and so on, like various other information. And we want to come up with a sample that maintains the distribution of the original data set. Like our sample should also hold 40% of male customers and 60% of female customers, very similar to what is happening in the whole population. Similarly, each and every characteristics that are very important, we want to retain the original distribution. So then we use the technique called as stratified sampling method. So by this way, what we do is we pick up a sample that in reality reflects or that's close enough to the actual population. So these are all the various sampling methods. Let's go into the tutorial video and then see how to implement each one of them using simple Python scripts. Come, let's go. Let's get into the tutorial and see how to implement some of those probabilistic sampling methods. As you see on my screen, first we need to import both pandas as well as numpy. So pandas because we are going to read the data from a CSV file, and numpy because we are going to make use of some of the numerical Python capability here to pick up the random sample. So let me execute this and import all the required packages. So then I'm going to read the data set that we are going to use today. So before going into the details of the data set, let me run this and then show the data set as such. So here we have a data set with an ID with few zones information as well as the weight. So here weight is the actual measure that we are going to use to see how the sampling different sampling methods produces an mean and how different it is from the original mean, that is the mean of the actual population. So now in order to get the mean of the actual population, let me run this script and then show you the details. So now here we have this original population's mean, which is 17.5093, and the total number of rows in our data set is 10,000 rows, and this is how the data looks like. So the first one is we are going to use the simple random sampling method to fetch a random sample of data, and then we are going to see what is the mean of this random sample and how different it is from the actual population. So in order to get a simple random sample, what we do is we use the data frame, the original data that we are considering here, and we use the method called .sample, and what we do is we pass the number of elements that we want in our sample, and what we say that it can be sorted based on ID, and the random sample can be picked up based on the ID. So now after getting the random sampling, what we are trying to do is we are going to calculate the mean for those sample. So we are going to use simply the mean mean functionality, and then we are going to calculate the mean of this particular sample rounded to 2 decimal to evaluate how different it is from the original population. So let me run this script here. So here what's happening is we are picking up like a random sample, elements, like 150 random elements from the original population using the simple random sampling method, and the mean of this particular sample is 17.72. So which is pretty much close enough to the actual population's mean, which in this case is 17.5093. So the reason why we are measuring the mean is to check whatever sample that we are trying to pick up, how similar or how close it is to the actual population. So here in this case, the only measure that we use is weight, but in reality the data set would have multiple attributes, and maybe we might have to take few of these measures to ensure that the random sample that we are going to pick up reflects or is close enough to the actual population. Because let's say we want to do a customer survey, which is like the steady like a customer survey to understand or study the customer's behavior. It is really important that the sample that we select represents the actual population. Otherwise, like whatever is the outcome of the survey or the research might not actually reflect the thoughts or the behavior of the actual population. So whatever effort that has been spent on the research or on the survey would totally go on waste. So it's really important for us to pick up a sample that reflects that's close enough to the actual population. So now moving on to the second method, which is called as a systematic sampling method. So here what we do is we use a systematic approach, like selecting every nth element. So here in this case what we are doing is the population that has about 10,000 records, and we want to pick up come up with a sample which is close to 150. So depending upon that, what I'm using is I'm using like this mathematical function here, like dividing the index by a number, and whenever there is no remainder, so pick up those elements. So we can alter or change this particular number here to suit the size of the sample that we are expecting. So what I'm going to do is I'm just going to I'm just going to show you the length of this particular sample. Yeah, so by running this one, so I can see that by dividing the index by 67, so the sample that I am able to come up is about 150. So now let's say I'm already using this number, I'm making like dividing it by 7. So when I execute this, we can see that the total sample size increases. So whenever the index is divisible, exactly divisible by 7, it pick up all those records and bring it to the sample. So we can alter this number according to our need. So by this way, like by using 67, I'm able to come up with a sample of sample with 150 records, which is close enough to my expectation, let's say. So now let's see how to calculate the mean for this particular sample. So I'm going to use the same method. I'm going to round off the values to 2 decimal places. I'm using the dot mean functionality here, and I'm using the measure weight to calculate the mean. So when I execute this particular statement here, so the systematic sampling method comes up with a sample that has a mean of 18.06. So the original population's mean was 17.5093, and here by using systematic approach, we come up with a mean of 18.06, which is still pretty close to the actual population mean. So it's fine. The next method is cluster-based sample. So what we do here is we try to divide the entire population into different clusters, and we randomly select 1 or 2 clusters depending upon the size and depending upon the requirement for the sample size, and we make use of it for like whatever the purpose would be, like to run the survey or whatever it is. So here what I'm doing is I'm saying that the group size should be 100, and what I'm doing is I'm going to create an group ID here, and I'm going to allocate all the records in our data set into the group ID. Each group should be of size 100. So that's what has been defined here, so which is being used in this functionality here. So once the group size of 100 has been reached, so the immediate next element or next record will be allotted to the new group here. So our record has about 10,000 records. So when we can have 100 records in a particular group, so we will be ending up with 100 such groups. So let me execute this and then create the group ID. So there should be like for our database, there should be like 100 group IDs with each of them having 100 elements within them. And using the cluster-based sampling method, what I'm doing is I'm using the same functionality that was used in the systematic approach in order to select a few random clusters and all the elements that is present within those cluster as part of the sample. So here in this method, by executing this, I can see that I have chosen like by dividing the group ID by 41. So there are about 100 groups. So we would be coming up we would be shortlisting about 2 clusters. So each one of them having 100 elements. So this particular sample will have 200 elements in it. So if you want, we can check it. Would have 200 elements in it, and the sample of this particular cluster based sampling method is 17.88, which I would say is closest to the larger population mean so far. So we can see there are 200 elements within this particular sample, and the sample mean by this approach is 17.88. So far 17.88, okay, 17.88 is second. Like the first one is the simple random sampling method, whose mean was 17.72, very close to the larger population. And what we can do is we can also use multi-stage clustering method. So here, after arriving at various group IDs, what we can do is we can subset all these into subgroups, or what we can do is we can select nth element from each of those clusters, so that we ensure that we have at least one element from all the clusters, and we can have the sample created based on that approach. So that would be a multi-stage clustering based methodology. And then the final one is the stratified sampling method. So as I said here, let's say, so in this data set, what we have is we have something called as an zone information. So in this data set, we have 5 zones. So whatever sampling that we are coming up with, we want to ensure that the distribution of the population based on zone should be retained in the sample that we are going to pick up. So this could be useful in many real life use cases. For example, let's say we have customers data. As I explained in the introduction, let's say the customers data, we have various characteristics such as the gender, age, the earnings, or the location where they live. And this sample that we are selecting, let's say we want to retain the actual distribution of the population. So then we have to use stratified sampling method. So by using stratified sampling method, what we are going to do is we are going to ensure that whatever parameter that we are defining, so here in this case, what I am saying is I am defining the zone. So whatever is the distribution of available for zone in the original population will be retained in the sample that we are working on. So in order to ensure that we use lambda function, and then we use this lambda functionality to ensure that the distribution would remain same in the sample as well. So let me execute this. So here I am saying that the sample size should be 150, and by executing this, let's see what's how good the sample mean is. So here stratified sampling mean is 17.01, which is again close enough to the actual the population of the mean of the actual population. And what we can do is, in order to ensure whether the distribution of the population as well as distribution of the sample are close enough, what I'm going to do is I'm going to use this group by functionality, and I'm going to print the actual distribution of the population as well as the sample that we have just come up with. So by executing this, so what this means is we have about 5 zones in our data set, and this is the actual number of records in the original population, and this is the distribution. So this will add up to 100%. And here that we have we have the count of number of records that is present in our sample, and here is the distribution in the sample. So we can see that the distribution in the actual population as well as the sample distribution are almost similar. So maybe here this figure should also be close to 20, maybe because of some rounding error it's coming up as 19. So all these values here, this particular column here, will add up to 100 as well. So whenever we want to ensure that we want to retain the distribution of the actual population, it's better to use stratified sampling method. So these are all some of the probabilistic based sampling method, and depending upon the scenario that you are working on, you can make use of these measures to identify which is the sampling method that is most appropriate for your use case. And that's it for now. If you have learned something new today, please give a thumbs up and subscribe to this channel. And if you think this might be useful for someone who's trying to learn statistics or data science, please share it with them. Bye for now. See you on the next session.